Hey Panthers, Miss Byrne here, and we're going to continue talking about algebra today. So before we get started, please make sure you have a pencil out, your composition notebook, or some kind of paper to write on. Again, lines is going to make your life a lot easier during algebra, so at the very least have some line paper, but if you're desperate, any paper will work. You do have a worksheet today that should be on your activities outline for the week. You will not need your textbook today, and you will not need a calculator today. Today we'll be learning how to write expressions and equations with letters standing for numbers or variables. That's what letters standing for numbers means. A reminder that if I'm talking a little too fast, which as I am right now, you know I do a lot, please just go ahead and rewind and rewatch so you can pick up on things that I may have said a little too quickly or you may have missed. You can also pause to look at pictures, tables, diagrams, anything really that you might want to just have a little bit longer time to look at to make sense of things. If you see that pause button in the lower right hand corner, that means that during that slide at some point you will be asked to pause the video. Please make sure you are prepared to do so. Here is a perfect time to practice that. So in your head, you do not have to write this one down. Go ahead and pause the video and ask yourself, what does inverse operations mean? And what are the inverse operations of addition and multiplication? All right, so the inverse operation, what inverse operation means is that it's an operation that undoes something else. So inverse operations are operations that undo each other. Subtraction is the inverse operation of addition, and division is the inverse operation of multiplication. So if you want to undo addition, you would subtract. If you want to undo subtraction, you would add. If you want to undo multiplication, you would divide. And if you want to undo division, you would multiply. Just a reminder, because I want to make sure we totally remember these terms because we will be using them a lot moving forward. Also, the format of these. It's really important that you know that the dividend and the divisor and their relationship with each other. The thing that I see the most mistakes on is people switching the dividend and the divisor in long division. It's really important that you remember that the dividend goes inside the division sign for long division. This will be the most common way you will see division in algebra, is using a fraction bar. So it's good to start getting comfortable with that. All right, so here we have a bunch of words that if you see could mean that is the operation that is expected from you in a story problem. So if it said, what is the total number of apples if Johnny has 4 and Kevin has 6, that would be 10. Maybe it says Lorenzo took away 6 apples from Johnny and Kevin. How many did they have? How many did Johnny and Lorenzo have in total? Then it might be talking about subtraction. So these are just words that might help you, give you clues as to what kind of operation you might need to solve a story problem. There are some that are repeated in different ones though. For example, less than is in both subtraction and division. It just depends on the context. Is it saying how many times less than something? Or is it saying just how many less than, not with the multiples? I also want to make sure that we know the different signs for multiplication and division. So remember, you can use the X, a dot, 2 variables or a variable and a constant next to each other are going to be also multiplication. Parentheses represents multiplication. And this little asterisk, which is the shift 8, also represents multiplication. In division, you have the division sign. You have a /, which is the shift question mark on your keyboard. If you can make a fraction, a traditional fraction, and then this would be our long division format. So this is trying to get us started and reminding us about what exactly it means to write an expression using words. So it says create a bar diagram to show 3 plus 5. So I had 3, and then I added 5. And then if I wanted to create a bar diagram to show 5 plus 3, I would have 5, and then I added the 3. are these two expressions equivalent? Yes, they are. In math, one of our properties is commutative property. And so that means I can move things around with addition and multiplication, and it will still be the same result. So 3 plus 5 is the same as 5 plus 3. So yes, both have a sum of 8. So now it says, how can we show a number increasing by 2? So, and then down here it says, can you prove this using a model? So I'm going to try and do that. To do that, I'm going to say, okay, so we have some number, a number. So I'm going to say A is a number. Okay, so I have a number A, and it's increasing by 2. So increasing usually means adding. So I'm going to say increasing by 2. Okay, I can prove this using a model. I'm going to draw A here. I don't know the value of A. So I'm just going to put an A there and put a question mark for right now, because I want to remember I don't actually know what that represents yet. It could be 1, it could be 1,000, it could be 1,000,000. I have no idea, so I'm not going to do anything. Then I'm going to draw 2 boxes, each of 1. And this would represent A plus 2. Some number A that we don't know, plus 2. So now it's your turn. I want you to try and figure out how we can show 8 more than H. And then I want you to try proving this using a model like I just did. At the end, I also want you to try to write an expression to show the sum of M and K. This should take just a couple minutes. Go ahead and pause the video now to use this as practice time. All right, so first thing I did was I actually did the model. So there's 8 more than H. Oh gosh. Oh, I just messed up the thing. Okay, so if 8 plus H, we have 8 more than H. So if we start with H and then we get 8 more, it would be H plus 8. So I can draw this using this model. So I have an H, and then I have 8 ones that are added together. For writing an expression to show the sum of M and K, I'm just going to add M and K. So it's going to be M plus K. This one is a little bit different. So in this situation, we have 3 less than a number. Oops. So we're going to say N is a number. Okay. And then 3 less than a number. So if we have N and we take less than is going to be minus. So it's minus 3 because it's 3 less than that number. Then now I'm going to be able to do that as my expression. Oops, so I did the expression first, and now I'm going to draw a diagram. So I have some number N. I don't know the value of that. And we're going to take away 3. So I'm going to draw 1, 2, 3, and we're going to take that away. So this would be my answer over here. All right, so now it's your turn. I'm going to have you draw a diagram and write an expression to show 4 taken away from a number. And then after that, how could we write an expression to show the number C being subtracted from the sum of A and B? So this is a couple different steps. So make sure you're paying attention to those different parts there. All right, go ahead and pause the video now to answer these and then play it once you have finished. Oops. Okay, so first thing I'm going to do is I'm going to draw the diagram for the first one. So it says, write an expression to show 4 taken away from a number. So I have a number n, and 4 is being taken away from it. So 1, 2, 3, 4. That's all getting taken away. And then I need to write an expression. So we have our n, and we're taking 4 away from that n. So we're subtracting 4. So that would be our expression for that one. How can we write an expression to show the number c being subtracted from the sum of a and b? So this part's kind of tricky because we have subtraction here, but we have addition here. So because it's saying subtracted from the sum, that means you have to add these first. So we're going to do a plus b first. And then it says, the number c being subtracted from the sum of these. So then I'm going to subtract c. So it would be a plus b minus c. We don't actually need to use these parentheses because of the order, in order of operations. A plus b minus c would be just fine. Okay, so we just did that one. Oh, here's another example. So start by writing an expression for the sum of a and b, and then now show c being subtracted from the sum. All right, so you're just going to think about it this time. Which of the following forms might we not want to use when working with variables? I'm going to read that one more time. Which of the following forms might we not want to use when working with variables? So the one that you're not going to want to use is this one. The reasoning is because this could look like the letter X. And A times B is different than A times X times B. Those are different. Those are not equal. So using the X is kind of hard. So you're going to want to use, so don't use that one. We're going to want to use either the dot, which is my personal favorite. This is the most efficient if it's appropriate. Obviously, if it's two numbers, constants, you can't do that. But if you have a variable, that's the easiest. And this would also work. So all three of those are just fine. Draw a diagram and write an expression that represents 9 groups of a number. So 9 groups of a number. So if I have, let's see, B is a number. I don't know what number it is, but it's a number. So 9 groups of a number. So we have 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, 8 groups, 9 groups. Okay, there's 9. Let's count those out. 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of B. Now that kind of looks like a 6. Bad choice of letter. It's a B. So I can write that as 9B. That's our expression. Notice how I didn't use a multiplication sign. I didn't use a dot. I just put them next to each other because if you have a constant and a variable next to each other, that means they're being multiplied. Draw a diagram and write an expression that represents a number divided by 2. So I'm going to let's see, C is a number. This is called defining your variable so that people know what your variable actually represents. So it's not like C is a cat. You know what number is it? Number of cats, number of pineapples, number of days of school, all those things. So C is a number. So it says C. So if I have C and I divide it by 2, there's 1 and there's 2. Okay, So that would be our answer. But I don't know what C is. So that would just be how you would draw a diagram of it. If I wanted to show that though, I could do with an expression, I could say C divided by, that's a terrible color for this, divided by 2. So that would be my expression for this one. All right, so I'm going to give you a little bit of time now. Well, you're going to pause your video and give yourself some time to answer these questions on your paper. So you're going to write an expression for each of the phrases. 2 divided by a number, it shouldn't be numbers, sorry. A number 6 times, 5 times a number, and breaking a number into 10 equal part groups. So go ahead and pause the video now so that you can answer those questions. Oops. Okay, so 2 divided by a number, I'm going to just say for all of these, n is a number. There we go, oops. Ah! Okay. Whew. Oh no. What is going on? Okay, well, I'm just gonna leave that. N's a number. 2 divided by a number. So 2 divided by n. A number 6 times. So that'd be 6n. 5 times a number. That would be 5n. Breaking a number into 10 equal parts. So you have n divided by 10. So those would be your answers there. Okay, I'm going to give you a little more time on these ones. They're a little more challenging. Go ahead and take some time to pause and solve these as well. Okay, so for these, we're also going to say let x be a number. Much smoother than last time. Okay, the product of 8 and the sum of 12 in a number. So that means I have to add first because we're multiplying 8 times the sum. Do you see that? We're doing 8 times the sum, but we don't know what the sum is until we add these together. So I'm going to put the sum first, which is 12 plus x, because we know x is a number. I'm going to put that in parentheses. And we're going to multiply that whole thing, because that is the sum of 12 and x, and multiply it by 8. And that would be our expression. So now we have 8 divided by 4 minus 2. Because it does not say the difference divided by the difference of 4 minus 2, it's just 8 divided by 4, and then we're going to divide 2. So we do this first. And then we're going to do the minus 2. So 8 divided by 4, or 8 over 4. I'll rewrite that over here. Minus 2. Okay. So I'm going to solve this one really quick just to show you something later on. So 8 divided by 4 is 2, minus 2 is 0. Okay, just so we can see that later on. So now I have 8 divided by the difference of 4 and 2. So now it's different, because now I have 8 divided by the difference, but I need to figure out the difference of 4 and 2 first, because that would be the difference. So I'm going to do 4 minus 2 in parentheses, and then we're going to do 8 divided by that. So it would also look like this. 8 divided by 4. Oh my gosh. 4 minus 2. Okay, so that equals 8 divided by 2, which equals 4. If you notice, 2 and 3 are very similar, but they have different answers because of the way they are written. So it's really important to make sure they are paying attention to those words that mean the answer of something, to determine what the actual order of operations is being asked of in the wording. All right, so you're going to have some time now to work on a worksheet on your learning activities outline for today's date. You get to pick one of 3 worksheets. So there is I would start at the more challenging one and then decide if you want to go a little even more challenging or a little less challenging based on that. I think most of you can do the more challenging. When you're done with that worksheet, check and fix your answers. The links are on the learning activities outline. They should just be the second page, whatever the worksheet is. Once all of your answers are correct, because you fixed them and you have extra time, go ahead and choose another math activity to do. So just a little bit of information on those 3 worksheets. So here's some example problems for each of them. Yeah, I think most of you can do the more challenging with Key, but if you are feeling like it's a little overwhelming, maybe start with the challenging with Key and then try to work your way up. If you are wanting the most challenging one, though, go for it. I think a lot of you could handle that too, and you might have a little bit of fun with it. Remember, you don't have to print the worksheets. You can either print it or you can write the questions in your notebook and just do it all in your notebook. That's totally fine. When you're done, check your answer against the answer key. Make sure you have your evidence somewhere safe. You will be turning it in on Friday. Email your teacher with any questions. If you haven't used your full 30 minutes, finish your time on one of the choice math activities, MobyMax, or completing a more challenging worksheet is totally an option. And the last thing I want you to do today is thank someone. I spelled someone wrong because I was really excited about this one. Thank someone at home for something they have done for you this week. Wow, my words were hard on that one. Okay, well, this brings me to reading through that stuff a little bit more. All right, well, that's it for, just kidding. So assignments this week. You do have a weekly reflection with evidence for each day due Friday at midnight, and it is due on Teams. That is tomorrow, I believe. You also have a formative Friday assessment. This will also be due on Friday and will be on Teams. All late work there won't be any penalties. So if you don't do it this week, you forgot or something, please just do it as soon as you can so that we can start giving you feedback and get you working on things that you might need a little extra help on. Another reminder about the 30 minutes of math each day. Let us know if you need anything. Also, use your classmates. They're a great resource. They can answer things that probably sometimes your parents might not be able to answer because they're not doing this every day. So if you're feeling stuck, I'm going to ask that you try to ask a classmate before you ask a family member, because your classmates are in this with you and this is what they're working on as well. So it might be easier for them to answer the questions than your parents because your classmates are literally doing this too. Also check Teams or ask on Teams. So for my class, Burns class, because I want to make sure that everyone has access to the answers. All right, have a good day. My battery's about to die. I'll talk to y'all soon.